Now it turns out that writing delta x can be kind of tedious, and writing x1 can be kind of tedious. So what I'm going to do is I'm going to make this a bit cleaner and turn this into the function that you're probably going to see as the limit definition in your textbooks. And that's simply this. Delta x is annoying to write, so we're gonna rename it as h. H is the distance between the 2 points of my slope. And x1, since I only have one x here, it's just x1, I'm just going to rename that x. So I don't have to write that subscript each time. And when I do that, this actually becomes a nice clean limit. The limit as delta x, which is now just an h, as that goes to 0, of f of x plus h, where x was my x1 originally and h was my delta x originally, minus f of x over h. And that's a really nice function. And you'll see that in textbooks just because writing delta x can be annoying and writing x1 is more tedious than writing x. Graphically, all this means is this. This function represents the slope at some point x. Okay. Well, really, it represents the point between x and some other x right here, x plus h, where h is the tiny little infinitesimal distance between those two. And m is just the difference. M is just rise over run. Rise is f of x plus h minus f of x, and run is just the distance between those two, h. This equation is very important, and it's going to be utilized for the rest of this year. We'll make it easy by giving it some shorthand notation, but this is the limit definition of the slope of a function at some point x. Remember, if you ever get confused with slope, all it really is just y2 minus y1 over x2 minus x1.